Hi guys, welcome back to the show. Thanks to Sibusisi for starting it off with us. We have a great question today from Jordan. Let's have a look at what he has to say.
My name is Jordan Taylor. I attend Florida Park High in Mitzvah. We are located in Florida, and behind me I have a question that I'd like you to take a look at.
Okay, Jordan, thanks for this question. We are doing first principles this week, so guys, you can send in your questions. The first question that we're busy with today is based on first principles. So let's have a look at what it has to say. It says, determine f of x from first principles if f of x is given to us as 3x squared minus 5. Okay, guys, so Sibusisi has just explained where that formula for first principles comes from. Now we're going to start putting it into practice by looking at this question. So guys, if you remember, the formula that was given to us is the limit as h approaches 0 of f of x plus h minus f of x, and that is all divided by h. Okay guys, so it's really important that you get this formula right. You are lucky enough that it does come out on the final paper. There is a formula sheet for you, and this formula is on there. So if you do forget it, don't worry, it is there, but make sure that you do copy it down correctly. So let's have a look at what we have to do. Okay guys, so when it comes to this, we have been given f of x, but now we want f of x plus h. So the first thing we're going to do is write down f of x plus h. But guys, we have to remember that we are looking for the limit as h approaches 0 of f of x plus h. So wherever there is an x, we are then going to replace it with x plus h. So we have 3x plus h squared minus 5, and then minus. Guys, I'm going to circle this in yellow over here. Okay guys, so this is very important for you. That negative sign over there, if you don't get it right, everything is going to go wrong. Okay? That negative over there is very important, and everything that you put after that must be in brackets, because when you distribute, your signs are going to change, and if you get that wrong, then nothing else is going to work out. And these are very long questions. They are easy marks in an exam, but guys, if you get that wrong, everything else, it's marks gone down the drain. So let's carry on with this. So we have then negative, and we're going to put this in brackets like I mentioned. We're going to have 3x squared minus 5. And this is all going to be divided by h. Okay, so what we've done is we've just put this into our formula, and now we need to simplify some things. So again, we haven't taken the limit yet, so we still have to write this down. We're going to have the limit as h approaches 0 of 3, and this binomial over here, we can just multiply it out. We're going to get 3x squared plus 2xh plus h squared. And now minus, okay guys, I'm going to put this negative into my brackets as is already. So I'm going to have minus 5 and then minus 3x squared plus 5. Okay guys, it's really important that you get that sign correct. Otherwise, like I've mentioned, it all goes wrong. Okay, now we just have to take the limit as h approaches 0. And we're just going to do some distribution and simplifying. So we're going to get 3x squared plus 6xh plus 3h squared minus 5 minus 3x squared and plus 5. Okay, so here we go. We're going to carry on. We're going to have that, again, the limit. Don't stop writing this down, because as soon as you stop writing this down, you said you have taken the limit. We're going to do some simplifying over here. We are then going to cancel 3x squared with 3x squared. We're going to cancel negative 5 with positive 5. And we're left with 6xh plus 3h squared. All of that divided by h. Okay guys, so we come to a very important part of our question over here. When we get to this part, what we want to do is we want to try and eliminate h. Because remember, as h tends to 0, we then get something that is undefined. We can't divide through by 0. So what we need to do is we need to try and factor out an h so that we can divide by that h, that we don't end up dividing by 0 when we take the limit. So this is very important when we factor out that h. And that's exactly what you want to do for each part of your question. So we have the limit as h approaches 0. And remember, you have to write this down. I know it's tedious, but guys, write it down. We're going to take out an h. We're left with 6x plus 3h. And that is also divided by h. Okay, guys, now we come to the point where we can divide h into h once. And finally, we can say the limit as h approaches 0 of what we have left in my bracket. So we have left in the bracket 3x plus 3h. And now, guys, we can take my limit. So when it comes to taking my limit, so you've seen throughout my whole question, I've been writing the limit as h approaches 0. It's when you take the limit that you stop writing the limit as h tends to 0. Guys, I know it's tedious, but write it down, because as soon as you stop, that's where the examiner is going to stop marking and you're going to lose marks. So as soon as I stop writing the limit as h tends to 0, we can then substitute my value for h into 0. So we're going to have 6x plus 3 multiplied by 0. And then we get 6x plus 3 times 0, and that's just going to be 6x. So that's that part done. Okay, guys, so when it comes to doing these first principles questions, I know by the time you get to your exams, you've already done rules of differentiation. So you can already go back and you know exactly what your answer is going to be by using those quick rules of differentiation to see what it's going to be. So if we have to do that, and we go back up to the top and see my equation is 3x squared minus 5. So if I have 3x squared minus 5, and I use those quick rules of differentiation, I know that I multiply and I subtract a coefficient, or I subtract 1 from the exponent, and 5, which is to the power 1, I subtract another 1 to the exponent. I'm then left with 2 times 3 to the x, which is then it's going to give me 6x, and 5 to the 0 is going to give me minus 1. Okay, but guys, remember, if I do the derivative of a constant, so the derivative of a constant is just going to give me 0. So I'm left with 6x. So guys, we can see over here that using those quick rules of differentiation, I can check my answer before I go through all the steps, so I know my answer at the end of the day after I've done all that differentiation by first principles. We're now going to go into another question, and then afterwards we're going to go into a break, and we'll be with you soon. So guys, stay tuned and we'll have a look.
Great stuff, Julian. Thank you very much for that question. That was absolutely awesome. Now we're going to go to a very powerful part of our show, which is a new segment that we have introduced. We call this the Wildcard. This is where we give you guys the opportunity to send us any question across the math curriculum. It might not be a question that is specifically asking about our topic of interest. For example, this week we're starting with differential calculus, and we are focusing on differentiation by first principle. So if you feel like maybe we have enough questions of those that you have seen, and you want to ask us something else that you are either doing in class or you're doing when you're practicing on your own, we give you the opportunity to send it to us. It might be a question on functions, or a question on geometry, or even patterns, maybe trigonometry, anything at all that you guys might have that you want us to look at. So we give you a chance to actually send us that question. So now we're going to go to a question which is going to be our wild card that comes from Hilton. Let's go and hear what Hilton had to say.
Hey guys, my name is Hilton from Zeros Combine. So I got a question that I would like you to help me with. I hope you can see.
Right. Thank you, Hilton. That is a geometry question. I hope you guys can be able to see that that is going to be a geometry question. Now, guess what? I have got very good news for you, Hilton. You just won yourself a 19-inch TV. A 19-inch TV just by sending us those questions. If you also want to win this, you can just send us your question. Take a video of yourself with any question that you want us to look into. We will be more than glad to look at it, and guess what? You also stand a chance to win these kinds of prizes. So Hilton has just won a 19-inch TV, and we will be in touch with you to send you your prize maybe around tomorrow. So if you also want to be like Hilton, just send us a question, guys. You don't have to do anything special. Take yourself a video video with your question, asking either about our topic of interest or anything that we might call our wildcard, and then you will stand a chance to win this. So now let's go and look at Hilton's question. It's a question that is asking us to do a lot of analysis on geometry. It's a Euclidean geometry question, and I know very well that when it comes to geometry, you guys always have challenges. So now we will try and help you to understand how do you really approach geometry questions. It turns out that geometry is very simple. The number one mistake that you guys make is you think you can just grab geometry in grade 12 and be able to run with it. If you probably were playing in grade 9 and grade 10 and grade 11, it's important for you to take a day or two going back to those concepts that were introduced in grade 8 and grade 9, because your geometry is that we are working with comes straight from the geometry that you've been working with. It's very important for you to make sure that you understand the grade 9 and the grade 8 geometry, and then build yourself towards the grade 10 and then the grade 11 geometry before you can answer your grade 12's work. So now let's see what Hilton's question had to say to us. So first of all, it says to us, complete the following statement. The angle between the tangent and the chord is equal to whatever the dots that they have there. Now, this is a knowledge question where we are required to just complete the statement by making sense of our theorems. According to my knowledge, the key word here is the word tangent. And there are three theorems that we were taught about tangent. The first one is that if you've got a tangent and it is drawn such that it meets the radius at a point of contact, the angle between them is going to be 90 degrees. The second one is that if you've got a circle again, and then you've got a tangent there, the angle between the tangent and a chord drawn in a circle, this angle here between the tangent and the chord, is going to be equal to a very special angle. It will be equal to an angle subtended by this chord on the alternate segment. So it's going to be equal to this angle here. And we call this the tan chord theorem, a very famous theorem, the tan chord theorem. So if you look at this question, okay, there is a third theorem of tangents that says if I've got a circle and I've got two tangents that are drawn from the same point, those two tangents will be equal in length. And these are the only theorems that I know that involve tangents from grade 11's work. So one of them is what this question is talking about. One of those is what the question is talking about. So let's take a look and see what will happen. The angle between the tangent and the chord, it certainly looks like this theorem, the second one. The angle between the tangent and the chord, this angle here. What is special about it? Is equal. So now we need to complete this and say it is equal to, it's equal to the angle subtended. Right, to subtend is to balance. Subtended by, right, subtended by the chord. The angle subtended by the chord on the alternate segment on the other side. So that's basically what we had to write there. It's a very simple question. You always get these kinds of questions where they ask you to complete. It's called a knowledge question. It's either you know it or you don't know it. And it's not complicated. It's very simple. Once you know your theorems, you can be able to identify which one the examiner is talking about. Now, the beauty of geometry again is this. Whenever we ask you a question, it means you're going to need it to work out the other subsequent questions. So at the back of my mind, I'm already thinking, why would the examiner bother themselves and ask me a question about an angle between a tangent and a chord? It is because they want you to use it to work out the follow-up questions. So let's see how this can help us to figure out the solution to the next part of this question. Okay, well, now in this part, we're given a diagram, a very interesting diagram. If you look at it, it looks very chaotic. Let's read the opening statement, which I call the love letter, to try and make sense of this particular story. We are told that in the diagram, points P, Q, R, and T lie on the circumference of the circle. We can see them. They are indeed around the circumference of the circle. And then we are told that MW and TW. So in this question, we're actually missing a point W here. There's a W right there at the bottom where these two lines meet. Right, so MW and TW are tangents to the circle at point P. Okay, fine, and T respectively, we can see that. And PT is produced to meet RU. PT is produced to meet RU at point U, which is very important information that is given to us. And now we are further told that an angle MPR is 75. We can see there's 75 degrees already in the sketch. PQT is 29. Where's PQT? It's right there at the top. There's 29 degrees. We're given 29 here. We're also given 75 right at the bottom. There's your 75 degrees. This angle here is apparently 75 degrees. And the last angle that is given to us is the angle QTR, which is equal to 34 degrees. QTR is 34, and there's your 34 degrees there. Right, so now we are required to, let's see what we are required to do. We are told that we are, let TPW be A, RPT be B, MPQ be C, and D. We have to calculate the values of A, B, C, and D. So let's look in the sketch and see if we have those. There they are. We've got A there, close to angle P. We also have B there. We've got that angle C right there. And we also have D this side. There's angle D right there where T is. Very powerful. So now we need to work out the solutions to all those variables. Now, I don't know about you, but most of the time, you guys always take questions. Whenever you're given a geometry question, you want to jump right into the questions and start answering them. And that is actually a bad technique. Do not do that. What you need to do is spend some time analyzing the question fully. Work out what I call the groceries. That will help you to eventually find the solutions to any question that they ask you. So I'm not even going to look at what the question is going to ask after what we have seen so far. I'm going to try and see, based on what I see in front of me on the diagram, can I be able to work out all these variables that they're asking me to figure out? Any and every angle that I can find based on the given information that we see here. So let's see what we'll do here. First of all, I will use red to try and complete this diagram to find the values of what you're looking at here. According to our geometry, we know that there are the theorems of centers, and there's also theorems about cyclic quads. In addition, there are also theorems that are talking to us about tangents, which we have already analyzed. Now, if I look at angle A right there, angle A at the bottom, angle A is the angle between the tangent PW as well as the chord PT. The angle between those two is equal to the angle subtended by that chord. If I am allowed to just highlight that chord there, this chord subtends an angle of 29 degrees right there at the top. So that angle of 29 degrees must be equal to angle A, and that gives us the value of angle A. So our angle A is equal to 29 degrees, and the reason for this is because it's tan chord theorem. If I continue to try and figure out what else we can get from this, you can clearly see that when we go to the angle C, let's go to, first of all, let's go to B. If we look at B, there's 75 degrees on that line MPW. MPW is a straight line. If I just redraw it here, MPW is a straight line. We've got 75 here. We've got 75 degrees right there. We've got B there, and we also have A. So there's B here, and there's also angle A here, which we have already found the value of. So we can apply angles on a straight line to figure out what the value of angle B is. So if I just start writing here, we'll just say angle A is 29 degrees. The reason for this is tan chord, very powerful. All right. The second part, we want B. We can see that A and B as well as 75 lie on a straight line. So A plus B plus 75 degrees equals to 180, and these are angles on a straight line. Angles on a straight line. Very powerful. Right. And then if I, of course, know what A is, I can be able to simplify this and say B is going to be 180 degrees minus 75 degrees, and then minus the value of angle A, which is 29. When we simplify this, let's go fetch our calculator to see what will happen here. Right, so if you get your calculator to just figure out the solution to this. Okay, fine, we're going to have 180, there's 180 minus 75, and then minus 29. We end up with 76 degrees, so that's the value of angle B. Angle B equals to 76 degrees, which we are going to put here. Get into the habit of writing things you have found in the sketch. It's important for you to keep updating your diagram because your mind understands pictures better than memory or words. What you see works better than what you remember. So if you find something, keep updating your sketch. Keep writing on the diagram, and that will open up a lot of other things that you probably couldn't see. It will help you to see more. Now let's continue and see what will happen there. I found A, I also found B. I need to find the value of C now. So C is an angle, that is a small angle that you see right there at the bottom. We want to figure out what the value of that angle is. You will notice that we already know that there's 34 given here. And if I apply angles on the same segment, this angle of 34 is equals to the angle by P there. It is going to be 34 here because these are angles subtended by the same chord. If I know that it's 34, 75 minus 34 will be able to help me to work out the value of C. So we start first of all by arguing that angle QPR, angle Q, right? Angle QPR is going to be, angle QPR equals to 34 degrees. And the reason for this is angles on same segment, right? Okay, once we are done with this, we can now be able to find C, because C is in fact 75 degrees. Sorry for that, it's 75, not 55. It's going to be 75 degrees, right, minus 34 degrees, which is going to give us 41 degrees, because 7 minus 3 is 4, and 5 minus 4 is actually 1. So we have 41 degrees, which I'm going to update and put there as 41 degrees. Now, quickly, the last angle that we need to find is angle D. Angle D is an exterior angle here. If you look at this cyclic quad, which I'm going to use yellow to highlight, there's my cyclic quad. This cyclic quad is a nice cyclic quad. It has got an exterior angle, and that angle D will be the angle that is subtended outside. It's an angle that is outside, not subtended, but an angle outside. It's an exterior angle to this cyclic quad. So that exterior angle is in fact equal to the interior opposite angle. So it is going to be equal to this entire angle here. However, I don't know what is the value of angle Q1. So I need to figure out what the value of angle Q1 is first. But angle Q1 is subtended on the same segment with angle B. So it is also going to be 76. If B is 76, then Q1 is also going to be 76 degrees. I've got 76 and I've got 29. 76 plus 29 will give me D. So I'm going to go on and say D equals to 76 plus 29 degrees. And the reason for this is it's because it is an angle, right, exterior angle of a cyclic quad. Exterior angle of cyclic quad. Very powerful. Right. Once I have this, just going to add those two to get the value of D. Let's see what will happen. Right. If you go to your calculator. Okay. Let's see what will happen there. Yes. So if I've got that, just that 76. So 76 plus 29 gives us how much? It gives us 105. Awesome stuff. So angle D is going to be 105 degrees. So that was a very brilliant question. Thank you very much for sending us that. It's easy. As long as you understand that you get the information that is given, the opening statement, you analyze that fully, you know your theorems from grade 11, you also know from grade 10 as well as grade 9, you'll be able to do very well on this question. So congratulations on that. And well, we will actually give you a prize very soon. We're now going to go to an ad break. When you come back, Julian is going to take another question. We're still continuing with our topic of the week, which is differentiation from first principle.